Yes. Any question from previous class? Any kind of question? No? Then we can continue our class. Last time I finished up the overview of naval architecture. Today I include find one video to show how ships are built. Let's start to see this video. 네. 유튜브 자체에서 그 사운드가 꺼져 있어요. I guess this video doesn't have any 사운드 끌까요? 이 비디오 자체에서 사운드가 꺼져 있었어요. 유튜브
Since every product of a certain design is similar to the other. But ships are not constructed this way. Every ship is based on the owner's requirement. Hence, even if the basic hull design may be the same, the dimensions, capacity, and systems used in one ship may be very different from another. The shipbuilding process is generally divided into a sequence, which we will see in this video. But before that, please do subscribe to our YouTube channel and don't forget to press the bell icon. Procurement of material. After the contract has been signed between the client and the shipyard and the detailed design has been carried out, the materials specified by the design is procured by the tendering department of the shipyard. The detailed design already specifies the type of materials required for each part of the hull, the thicknesses, and the grade of steel. Stowage of plates. Once the steel plates are procured by the shipyard, they are stored in the stockyard. Plates of different thicknesses and grades are available in standard dimensions. There are usually two positions of stowing plates: vertical stowage and horizontal stowage. Many modern shipyards carrying out multiple projects also practice methods of plate stowage scheduling at the same time. In this method, each plate is marked with the project it has been designated to, and they are stored in an order that is synchronous with the working schedule or the master plan of the shipyard. Plate preparation or surface preparation. When a plate is brought to the shipyard from a steel plant, it is not ready to be used for construction. Hence, it needs to be prepared for the same. This includes two major processes: straightening and removal of residual stress. The plate obtained by rolling in the steel plant is not completely straight, though it may visually appear to be so. Plates may also be mangled during transit from plant to shipyard. Hence, the straightening is carried out once the plate reaches the shipyard. Priming and drying. The plate is passed into a chamber in which a primer is sprayed on complete surface. Priming protects the steel from corrosion. The primer applied is usually a zinc-rich coating, and it should be chosen such that it does not interfere with the welding and bending of plates. Plate cutting. The surface treated plates are to be cut into desired shapes and size in order to be developed to the required three-dimensional shape or used as straight plates for other structural components. Plate bending. A ship's hull usually has multiple curvatures, unless only straight plates are used in the design. It might seem quite easily achievable on a 3D modeling software package, but production of the same is a complex process. Special methods are used by the shipyard to bend and develop steel plates and stiffeners to require 3D curvatures in order to make them fit the shape of the hull. Assembly. Once the plates and frames are prepared and given the required shape, they are welded according to the structural drawings prepared by the design department of the shipyard. The hull is divided longitudinally into blocks, and each block is again divided into assemblies and sub-assemblies. During the shipbuilding process, each ship block is brought to the building dock, where they are erected with cranes as per the welding sequence. After each erection, welding is carried out on block joints. Improvement in alignment are made by use of proper jigs for curved shell panels, by using laser alignment tools, and by use of proper welding techniques that have lower heat input. Most of the machinery, especially those which are bigger in size, are fitted during this process. The ship is ready from the outside and is then painted using anti-fouling paints to reduce hull corrosion and resistance. Launching. Many big shipyards now construct ships on building docks, which are then flooded, and the ship is towed out to the outfit basin by using tugs. But most shipyards still follow the traditional process of launching a ship. Today, launching methods have become safer and more proactive in approach, as computer programs helps the engineers to estimate the load on the ship during launch. Outfitting. After launching, the ship is berthed in a fitting out basin for completion. The main machinery, together with auxiliaries, piping systems, deck gear, lifeboats, accommodation equipment, plumbing systems, and rigging are installed on board, along with whatever insulation and deck coverings are necessary. Sea trials. Once all the construction and outfitting work is completed, the sea trials are carried out by the shipyard authority in the presence of designated representative of the ship's owner and ship surveyor. Some tests include ship trials, turning circle test, crash stop test, zigzag or camp overshoot maneuver, spiral maneuver, engine trials, and Aston test. Shipbuilding is a complicated process which involves several departments working together to build a vessel which is not just seaworthy but is also equally efficient in terms of both operations and economics.
Great. Question on the video? No? And go on to what's not for today. Ocean engineering. So this is the book, the textbook, second textbook we'll cover for the ocean engineering. elements of ocean engineering. And the book has chapters of 12. We will cover some of them with the green color as well. Okay, just an overview of ocean engineering. And ocean is a frontier, unexplored frontier on Earth. Surface area 70%, water 97%, unexplored underwater area 95%. Dive deep trench 11,000 meter. What is the highest mountain? What is the height? 10,000. 10,000? Only less than 10,000. So it's deeper than the rest, highest place. Oh, but same order. Because water is cooling. And more on fact, world trade is carried by ocean. Korea 99%, because Korea is kind of an island, because North Korea. But in terms of weight rather than price, because expensive small items are carried by airplane nowadays. Faster, but expensive. But heavy, big ones are carried by ship. That's why we should be careful about this percentage, because it is by weight, not by price. Water, 2% is frozen. Inland is very small water. Life on Earth, 80%. Protein for human, coming from sea, fish production, exceeds that of cattle, sheep, poultry, eggs. In terms of prey, volcanic activity, and oil. Oil is more coming from the sea rather than land, because the land side oil reservoir is empty now. We already used many of them. So the percentage will be increasing. This third percentage is increasing now. Here's another video. States, Miami, California, or Gulf of Mexico, South America, yeah, Africa. Middle East, Saudi Arabia, India. Malaysia, Indonesia, Thailand. And Korea. Here there is a big stream front. What is it? Kushyo. right? So this one is made by NASA. They connect images coming from satellite. Satellite images combined together to be a video. Anyway, looks very pretty and very nice. So what is ocean engineering? There's a definition that engineering principle is applied to the analysis, design, management, function in a water environment such as ocean, lake, and rivers. Related disciplines are naval architecture, we already covered this one. Marine engineering, usually called the engine part, engine portion of the ship. Or coastal engineering and offshore engineering. So offshore, the reverse word of offshore is onshore, right? Onshore, near shore. Offshore, onshore. And onshore is similar to coastal engine. Onshore is. And also fish farming, another name is aquaculture. And fish farming is becoming more and more important for providing protein to humans. Naval architecture, we already covered this one. There is a hull structure, propulsion system, the engine and propeller, surface vessels, and underwater submarines. Marine engineering is usually talking about engine itself of the ship and nearby ones. So energy and mechanical system used on marine vehicles. And this one looks like a turbine, steam turbine, probably steam turbine. Steam turbine is also used for power plant, nuclear power plant. Nuclear power plant is generate electricity by using steam turbine like this one. The size is measured. And this one is engine, diesel engine for ship. So you can imagine the size because there is a human body there and there. So this big engine is located inside the ship. How many storage or floors? Looks like 5 to 10 floor height. So it can be how tall it can be. 10 to 15 meters high. So big engine. And this engine can be produced. How much horsepower it can imagine? How much horsepower the engine can produce? 10,000. 10,000. 10,000 more. We talk about this topic the other day, first day of this class. Are you there at the beginning? Yes, yes. We talk about what is the horsepower small car, your car. One guy replied well, right? For the engine. More. 100,000 horsepower, but a little bit less. So nowadays, biggest diesel engine produce about 80,000 horsepower. So it looks like this one can produce about that order of horsepower. And we talk again at that time. We talk about the aircraft carrier has more power than 80,000, right? It is 100,000 and more, and they produce that power using nuclear power plant inside the ship, the aircraft carrier, or other way, steam turbine. So steam is generated by nuclear power or other ways, boiler, Okay. Coastal engineering. So I told that onshore and offshore, so near coast or near water area. So coastal engineering applies engineering principle to systems operating in coastal zone. So this one looks like Busan port. Busan is second largest city of South Korea, southeast corner of the Korean Peninsula, and probably 5 to 10 position of world port is varying between years. So it's a big one around the world. And this one is there is a old Busan port and new Busan port. And this one is in early days of new Busan port. Now it is more complicated because this picture looks like an old one because it is not operating at this time. So now the new port is fully operating. So the picture should be more complex. And this right-hand side, this is airport. Probably picture coming from Japan. I'm not sure, I guess. So one time Japan constructed a floating airport. But this one is not floating airport. This is based on probably conversion of an island, and similar things are happening in other days. Also, Korean is near Busan. The government is talking about another Busan airport around the island, and probably many of you arrived Korea through the Incheon airport, and Incheon airport was built around a small island near Incheon. So basically that was an island, but it's bigger than this one. So this kind of one is we call coastal engineering. So size is big, the port and airport and others. And offshore engineering is reverse all the onshore engineering or coastal engineering. So offshore is far away from the land. Right? So deep water there. And harsh water. The weather condition is harsh. So offshore zone, which implies deeper water outside the coastal. So it looks like a drilling ship, not ship, drilling plant for the oil and gas. Because I saw this is a tower, drilling tower. So water depth probably several thousand meters or several kilometers water depth. Very deep. And this one we already showed this one before that it looks like a energy island. They have a wind power system and wave generator system and also other kind of ideas of collecting energy, renewable energy. So the scope of ocean engineering, once again, the naval architecture, marine engineering is half covered. The main part should be coastal engineering and offshore engineering. If you have any question, just raise during my talk. Anytime. Or using chatting. You don't have any chatting. Okay. Port and harbor. Long Beach. Anybody knows about where is Long Beach port? Long Beach. Long Beach is a port of the Los Angeles. Just below the Los Angeles city. Is it connected? Probably connected. Long Beach. He's saying beach is long. But here's the ship. And then there's a big backyard. We call this is container yard. Containers are stored there. Right? Something like let's say storage place for cargo. Let's see. For the postal system, post office, we you or one of us, anybody can visit post office to receive postal service and or to send someone, right? But their job is collecting all the incoming post and also deliver out in another by reverse way. Once those collected one goes to the big area, and the big area we call the sorting area. If you want to send your a small cargo or letter to your home country, then that post or mail or cargo should be arrive at the sorting area to sort down them to the destinations. That kind of thing is happening in this backyard of the container. The containers are coming from all over the United States or nearby California area, right, to here, and then sorting out there. Also, the ship is delivering containers and then also uploading containers. Right? So it should be sequenced. Once ship is arrived, all the cargo for the Long Beach area should be unloaded. Right? After that, the ship uploads cargoes, containers to the ship, and then pass away, right? Go another way, place. And then after unloading all the cargo from the ship to here, this container yard, then there should be also another kind of a sorting or delivery, dispatch to all the places around the United States area of California. So that we need a large backyard like this one. And the ship is coming and back. So that's why the port is big and long. So you guess how many ships can be served in this area, right? Many, more than 10 or 20 something. Now, the right-hand side is Baltimore. Baltimore is east coast of United States. But this one is very long history and looks like a smaller than this one. It's small. And Baltimore was very big port 200 years ago when the England and people from England and Europe coming to the United States. So at that time, there should be sailing ships, wooden ships at the beginning. Right? Nowadays, this port is too old and too small for big ships. So they convert this port as a tourist point. So that you can see only yacht and good viewing buildings or apartments. Not commercial big ships. So they changed the role of the port as economy and history. Coastal structures, jetty. Jetty is for ship is docking. Ship is touching the port. Because ship is big, if the ship is coming too fast, then port can be break or ship can be break. Right? It's collision there. We should have a soft touch of the ship. That kind of thing is happening so that there is a protection or soft material is there. Growing looks like this is a sand beach, looks like a tourist zone. So they want to protect the sand beach, not go away through the water flowing channel. Flowing is also that people can walk through this place to see. Which breakwater is for protecting port from the incoming large waves when storm is coming. Last night we had the typhoon pass through the Korean peninsula, right? And that kind of thing, all the ships are coming into the port, and breakwater is functioning there to protect the port from the incoming big waves coming from Texas. Coastal bond, I don't know what is this. Anyway, it looks like they are making the beach using a sand pouring. Dredging, we already covered this one, dredging last time. In Incheon and Yellow Sea, I told that Yellow Sea. Can you remember what is the deepest depth of Yellow Sea? 80 meters. It's a big ocean compared to Korean Peninsula or China, right? The probably area of Yellow Sea can be around the same size of whole China, right? So it's a big, not so big, but pretty big size, but is shallower. Then big ships cannot come to the port of Incheon. That's why we need to have a dredging every day, only for the passageway of the ship. So the ship has a map for the pilot. Right? They show the highway only for the ship on the map. And then the interesting thing is every 10 years, they build new islands because of this dredged soils are poured down into some place on the nearby ocean. Then it creates a small island every 10 years. It's good. Right? So digging the passageway and also create a smaller. And the type is cutter suction. Cutter suction is similar to land-based grabbing type. And hopper type, hopper type is grabbing one, like a hand. And suction type is just piping and something like vacuum cleaner. They storing the soil or mud there and then vacuum out the water, including the soil. We call it suction. And this one shows a big port around the world. So probably this is Rotterdam in Europe. Rotterdam is a big port there. I guess Long Beach looks like this one. Oh, this one. But anyway, you see that the big port in United States is near East Coast or Gulf of Mexico. And then you see that Singapore is here, and also Japan, and Busan port looks one of them, and then also big China port. This one is a port of New York, of United States. You see that Brooklyn, and then Hudson River, Manhattan is there, New Jersey, you heard about this one. And then you see that there is a Newark is one of the airports there. New York has 3 airports nearby. One of them is Kennedy, the other one is Newark. And Newark also have a port of Newark, a container terminal. And Mahar and APM is a famous company for cargo handling terminals. The company owns their own container terminals, in addition to local authority, New York, New Jersey port. Okay. Anything else? Okay. Question? Any question? No. And we may have a 5-minute break. Let's start.